That is chapter 3, current electricity. I have already told the what is the electric current. What is electric current? But I want to repeat it for the reason sometimes is it is a long gap. It's a long gap. That's why I want to repeat the concepts of electric current, and I want to repeat the concept of potential energy also, or potential difference and potential also. But at first we want to know what is electric current. As I already told you, when free electrons moves in a conductor, due to movement of free electrons, we get currents. That's why here is clearly told that the flows of charge in a definite direction constitute the electric current, and the time rate of flow of charge through any cross section of conductor is a measure of current. That means electric current is equals to I is equals to Q by T. As I already told you that the current is the measure of flowing of charge per unit time, per unit cross sectional area. मतलब क्या बोल रहे हैं हम? Through the electric current represent the direction of the flow of positive charge. That is the direction of electric current. That means I want to say that, wait a second, that means I want to say that when charge, or you can say, you can say more satisfactory, that the electrons, the flow of electrons per unit time or charge is called electric current. Okay, now that is additional part, that is for class 12 students. Drift velocity, I have already told you that that is the expression F is equals to minus E into E, A is equals to E by M. What is relaxation time? I have already told you. Although you are you have no this syllabus for your class 10th grade. Relation between current and drift velocity, that is also different thing for you. I have already discussed this expression in your class. Vy is equals to ml by a n square into tau, that is called r. V by I is equals to r, that is the expression, that was the expression for that. I have already told it. Although you have no this syllabus for your class 10th grade. Yeah. I have already discussed about slope. What is slope? What is the slope of a graph? That is already told. that was already told in your class. We discussed about Ohm's law. What is Ohm's law? Ohm's law states that the current I flowing through a conductor is directly proportional to the potential difference across the ends of conductor. Ohm's law states that the current I flowing through a conductor is directly proportional to the potential across the ends of the conductor when temperature is constant and the physical another physical things are also be constants. So that's why I already told. That's why I told that there is a temperature term which is dependent on. Wait a second. If temperature is increased, the number of electron increased. Number of electrons increased. Okay. So then it is R, it's not constant. I have already told about it. Okay. So Ohm's law states that the current I flowing through a conductor is directly proportional to the potential difference V across the ends of the conductor when when the temperature is constant. That is the deduction of Ohm's law. I have already done it to the class. Deduction of Ohm's law, we know that Vd is equals to E by m into tau, and E is equals to V by L. Vd is equals to EV by ml into tau. I is equals to NEA Vd, and I is equals to NE Vd. The value of Vd is that values are applied here, and the expression, this is the main expression for our Ohm's law. Okay. And I have already told the theta is the slope of this graph, this slope is actually theta 1 is not the slope, tan theta 1 is the slope. If theta increases, the resistance also be increased. If V is equals to V is the direction of y axis and I is the direction of x axis. Actually we put the values of I in the x axis and put the values of V in the y axis. V is equals to IR, Y is equals to mx. That is the expression for straight line. That is the equation of straight line. Y is equals to mx plus c. That's why y supposed to be V and x supposed to be y. If the quantities voltage and current reversed, then the R will reversed. That means that the slope of this graph shows the resistance actually. No. So tan theta is equals to V by I is equals to R. R1 greater than R2. R1 greater than R2. Why R1 greater than R2? Because theta 1 is greater than theta 2. Theta 1 is greater than theta 2. I have already told about it. Okay. The device of a substance which do not obey Ohm's law that is the new topic for you, and that is starting point of our new session, of our new lecture. From there, it is a starting point actually. The device or substance which do not obey Ohm's law, that means gases, crystal, rectifiers, thermionic valve, hmm, transistors, etc., are known as non-ohmic or non-linear conductors. That is the non-ohmic or non-linear conductors, conductors which do not obey Ohm's law. Conductors for this VI curve is not linear. Static resistance R stage equals to V by I is 1 by tan theta. Dynamic resistance R dynamic is equal to del V by del I is equals to 1 by tan phi. That is the angle tan phi, and is it a theta? That is ohmic conductor, ohmic conductor, static conductor. It's obey the Ohm's law very carefully, and that is the non-ohmic conductor. That is the graph for non-ohmic conductor. You have already you have seen that. You can see this curve shows the non-ohmic curve, and the slope is tan phi, that is represented here. Okay, so we need to know what is ohmic conductor and non-ohmic conductor. Ohmic conductor are those conductors which actually obeys the Ohm's law. The device and the substance which obeys the Ohm's law is called ohmic conductor, and the which do not obey Ohm's law, that is called non-ohmic conductor. The electrical resistance, now the electrical resistance R, that is R, that is R. The electrical resistance of a conductor is obstruction posed by the conductor or to flow of electric current through it. That is, electrical resistance of a conductor is obstruction, that is obstruction posed by the conductor to flow the electric current through it. As I told you before, the kernels of atoms which obstruct the motion of electrons, that is called electrical resistance, and that is R is equals to V by I in equation we have already studied. The SI unit of electrical resistance is ohm, volt per ampere. That is the unit of V is volt and I is ampere. Dimensions of electrical resistance. The potential difference, that is voltage. Voltage is equals to work done upon charge. It was studied in our classes when we completed our topic potential difference. Work done upon charge by current. So ml square t to the power minus 2 by at by a. That means that is the dimension of electric current. That is the dimension of electric current. Work done, W is equals to W is equals to W is equals to W is equals to what? What? F into S. Fs. The dimension of F is equals to m m L square T square into displacement into L, sorry, mlt to the power minus 2, sorry, mlt to the power minus 2 the force is equals to mass into acceleration, mass into lt to the power minus 2 is the acceleration. That's why the dimensions or dimension of work done is equals to what is this? M L square T to the power minus 2. That is the dimension of work done upon charge. Charge Q is equals to I into T, na? Q is equals to I into T. So I have already told that I is equals to, that is ampere A and time is time period T. That is the dimension of Q. That is the dimension of Q, and current is equals to A. So that is A square by T, ml square T to the power minus 2 by A square into T, the T to the power minus 3, and ml square T to the power minus 3 and A square A to the power minus 2. That is the dimension of resistance. That is the dimension of resistance. That is the dimension of resistance. Okay. We rub it at first. That is the electrical resistance of conductor, the obstruction possessed by the conductor to flow the electric current through it. So that means R is equals to V by I, that is the electrical resistance. Now we have already that is the dimensional formula of uh, electrical resistance, and now we need to study about electrical resistivity or specific resistance. That is our topic right now. Yes. So the resistance of conductor depends upon the following factors. That is the factors which that that the resistance depends upon. Okay. Length the the okay. So here want to say R is directly proportional to L. Sorry. R is directly proportional to R is directly proportional to R is directly proportional to L and inversely proportional to and R is inversely proportional to A. That is already discussed in class, but by derived velocity, the concept of derived velocity, or from this expression. From this expression I have already told the resistance is directly proportional to L and inversely proportional with A. This constant I have told that constant is called resistivity. The resistivity rho is equals to mn square upon tau. I have already told about this expression in our previous classes. 2 to 3 lectures is 2 to 3 lecture was needed for this class. Okay. So the resistance of the conductor depends upon following factors: length. The resistance of R of conductor is directly proportional to I, directly proportional to R. Directly proportional to L, and area of cross section A. The resistance R of the conductor, is inversely proportional to A, that is already discussed here. Okay. The resistance of conductor also depends upon the nature of the material. I have already told the rho is dependent only on the nature of the conductor and temperature. I have already told about the resistivity, which is only depends on material or temperature. That is already discussed in our classes. That is the most important thing I have already told. Many questions we have done, many numericals we have done from these concepts, and further classes we have we will do many types of questions or conceptual questions from these expressions or uh, from this equation, from this expression जो r is equals to rho l by a, r is equals to rho l by a, that is our that was that is the that will be the this will be the next further this will be the next topic about our concern. Okay, so next, that is conductivity. What is conductivity? I have already discussed about it. Reciprocal of resistivity is called conductivity. Sigma is equals to 1 by rho with unit of mho per meter and dimension of this, that is the dimension of sigma, that is called conductivity. That is called conductivity. Okay, that is called conductivity. Next, that is not specified in your chapters or on your syllabus also. Now we want to study about the stretching of wire. Stretching of wire. Okay. That is the most important thing for your syllabus. If a conducting wire stretched its length, increase area of cross section decrease, so resistance increases but volume remain constant. Suppose for a conducting wire before stretching its length L1 and area of cross section A1, radius R1, diameter D1 and resistance R1 is equals to L1 by A1. Now before stretching, that is the dimension of this wire before stretching, and that is the dimension of wire after stretching. Okay, the volume remains constant. That means A1 I1 is equals to A2 I2. That is the volume remains constant, na? Okay, we know the volume of the cylinder pi r square h, that is depend on length and the radius of the cross sectional area. So length is that in this case the cross sectional area decreased but length increased. After all, the volume will remain constant. Okay, so after stretching the length L2 and area of cross section A2, but the volume is constant. That's why the ratio of resistance before and after stretching, so that's why R2 is equals to L2 by A2 and R1 is the rho L1 by A1. I told that rho is material dependent quantity which is dependent on material only and temperature also, not dependent on L and R. So R1 by R2 is equals to L1 by L2 into A2 by A1 is equals to L1 by L2 whole square. That is the ratio we have to find. That is the if length is given, the r proportional to L square, r1 by r2 is equals to L1 square by L2 square, that is L1 by L2, A2 by A1. So A2 by A1 is that is called L1 square by L2 whole square is equals to A2 by A1 का whole A1 whole square is equals to R2 by R1 whole square whole to 4. That was very difficult for शिवम. शिवम अरे मोबाइल टा दे ना भाई, ये कनेक्शन भाई सुना ये ऐसे मूवमेंट टेप ना. Actually connection is lost for some reason. So there is R1 by R2 is equals to L1 by L2, that is L1 by L2, and A2 by A1. So L1 by L2 whole square is equals to A2 by A1 whole square is equals to R2 by R1. A means pi R2 square and A1 means pi R1 square. So pi cancel out, R2 by R1 whole to the power 4, that means D2 by D1 whole to the power 4, that is we already know. So A2 by A1 is directly proportional to L1 by L2. L1 by L2. From here you can calculate A1 by A2 is equals to L1 by L2 by L1, or A2 by A1 is equals to L1 by L2. I put it here, and result is in your result is front of you. I have already discussed about it in classes also. So R proportional to L square and R proportional to 1 by R to the power 4. Yeah, R1 by R2, R2 by R1. That's why it is anti-proportional or inversely proportional to R, and this is the this is L1 by L2, R1 by R2. That's why that is proportional to that. Okay, I have already told about it also. Okay, for today it's enough. I will start from here tomorrow. Okay.